Hello, everyone. My name is Radu-Daniel Vatavu, and I'm a professor of computer science at the University of Suceava, where I lead the Machine Intelligence and Information Visualization Research Lab. First of all, thank you very much for your kind invitation to be a part of this conference, and I'm really looking forward to having a great discussion with you on topics in human-computer interaction. I'm always happy to share our results and the things that we do in this amazing area of research involving humans and computers interacting. And we also frequently extend our work beyond human-computer interaction in order to address research questions in connected fields. And these include extended reality, ambient intelligence, and accessible computing. So thank you very much for having me. The topic of this keynote is based on some recent work that we conducted in artificial intelligence in order to apply it in ways that can provide extra modalities for humans in the context of human augmentation and human computer integration. So I will present results about what I see to be a great opportunity that we have as a community to use emerging generative AI technology in order to innovate in terms of design possibilities towards new kinds of input and output modalities. So, this keynote is about a new perspective on artificial intelligence that is being applied to multimodal interaction. And of course, AI has always been central to systems implementing multimodal interaction. For instance, it has been used for sensing intentions and actions of users in specific smart environments, also for sensing emotion, for generating adaptive feedback. And over the last decades, AI has been shaping our interactions with computer systems and computerized environments of various kinds. And these range from personal assistants that are enhanced with conversational skills to robotic systems that act and behave increasingly more natural, to smart objects and smart physical and virtual environments, which include extended reality, that feature interactions that are adaptive due to their ability or the ability of these systems to understand and be aware of the context in which they are being used. And the large majority of these systems, they feature interactions that primarily involve natural human modalities of expression and communication, such as gestures and speech and eye gaze and so on and so forth. In this context, where we have AI that intersects social interaction, the current perspective on the use of such techniques in the human-computer interaction community has been mostly one of enabling technology. And according to this vision or perspective, AI accommodates and supports existing human modalities such as gesture and speech input. This is an approach that has primarily taken the form of applied machine learning or applied deep learning to various natural human modalities, where we want the interactive systems to be able to recognize human gestures and natural language as accurately as possible. I refer to this approach as AI being used as a tool for multimodal interaction, or for short, AI as tool. Now, while this perspective has worked well for many application areas that benefit from multimodal interactions, for instance, video games, entertainment applications, learning environments, and so on, it is nevertheless a perspective that falls short for what is yet to come, which means emerging areas of computing that involve new kinds of environments, new kinds of technology addressing human augmentation and human computer integration. For example, the human computer integration paradigm emphasizes this symbiosis, this fusion between humans and computer systems. And therefore, it raises totally different questions about what is control and what is user agency when integration with computers comes to complement interaction with computers. For instance, in a 2020 article about the next steps for human-computer integration, the authors note the following, quote, "In designing the future of computing, it is no longer sufficient to think only in terms of the interaction between users and devices. We must also tackle the challenges and opportunities of integration between users and devices." End of quote. So, in this context, human augmentation and human computer integration bring up distinctive nuances of what will be like in the future to be human. As part of this keynote, I connected this vision of integration and interaction with computers in order to propose you the perspective of going beyond the current paradigm of AI as a tool. Because this paradigm comes with many limitations, and basically it just accommodates human modalities that already exist. And the broader goal here is to introduce the concept of AI as a modality, where we have various embodiments of AI that are capable of generating entirely new modalities. And these modalities are complementary to those that users can access on their own using their own bodies. To give you an example, imagine a robotic arm that has a certain degree of autonomy and it can move, it can act, it has on its own, it has goals of its own. So this arm can generate a new modality that is beyond the user's control, and because of that, it is different in nature from all of the other modalities that the user has with their unaugmented body. So I believe that this new perspective of AI as modality can lead to new forms of multimodal interactions that are distributed across humans and AI embodiments. So, in this context, I also advocate for revisiting what is the commonly accepted notion of modality in our community in order to enable explorations of novel types of modalities that are not just innate to humans, but they are being generated by AI that embodies various form factors. Prior research in multimodal interaction has centered on what is human, because the goal was to support existing human modalities such as gestures and speech and so on through applied AI techniques such as machine learning. So, from this perspective, AI is just a tool to support existing modalities. However, I propose that this perspective on AI is just a historical consequence of how modality and multimodal interaction have been defined and understood in the community. So it is useful to start with a discussion of what is our present understanding of modality and its various connotations and nuances. Multimodal interaction techniques enable users to employ different modes to interact with computer systems and at large to interact within computerized environments. These interactions are mediated by what we call multimodal user interfaces that, and I quote, seek to leverage natural human capabilities to communicate via speech, gesture, touch, facial expression, and other modalities, bringing more sophisticated pattern recognition and classification methods to human-computer interaction. End of quote. So this is from a review of multimodal interaction by Matthew Turk from 2014. So you can see that by following this perspective where AI or pattern recognition is being used in order to support multimodal interactions, there are two objectives that can be identified for multimodal user interfaces. The first objective is to support, to accommodate users' capabilities, perceptual and communication capabilities. The second objective is to integrate computational skills in the real physical world by offering humans more natural ways of interaction with computers. And these two objectives are frequently discussed in the scientific community, in the scientific literature of multimodal interaction and multimodal user interfaces. But they essentially focus on existing human abilities of communication, self expression, interaction, and do not typically move beyond that. Now, there are several nuances to understanding what is modality. For example, I'll start with a paper in multimodal integration from Blattner and Glinard, who considered modality as being defined according to two measures that are orthogonal. The first one is input versus output, and the second is human versus computer. So, according to these measures or dimensions, the authors note in their 1996 paper on multimodal integration the following, and I quote: human input modalities refer primarily to our sensory abilities, whereas computer output modalities refer to information encodings and the nature of our interaction with them. End of quote. And all this should be very familiar to us because we are used to think about multimodal interaction in this way, which means a clear separation between what is human and what is computer, and what is input and what is output, according to the two dimensions. And many other researchers have explicitly considered modality only in relation to human modalities. Another good example is a paper from 2009 by Nico Sebe, who presented an overview of the challenges and perspectives and multimodal interfaces at that time, and who considered modality to be, and I quote, a mode of communication according to human senses and computer input devices activated by humans or measuring human qualities. End of quote. And you can again see the focus, the centering on what is human and what are human modalities for which we provide pattern recognition techniques in order to augment them, in order to support them, in order to accommodate these modalities in interacting with a computer. And other similar perspectives abound in the community, and ultimately, they all fall under the paradigm of AI being just a tool to support modalities that are innate to humans. In this context, the question is whether this paradigm, where AI primarily supports and accommodates human modalities, is still suitable for emerging application areas that involve human augmentation and human computer integration. And my answer to this question is no. And therefore, I propose that the future of multimodal interaction should transcend these limitations by radically redefining what modality is and what multimodal interaction is through integration of modalities that are generated and delivered by AI embodiments. And this represents a transition from the current paradigm of AI as a tool to a new paradigm called AI as a modality. Now, in order to move beyond the current paradigm, the concept of modality must be understood more broadly than what currently is. And we are lucky that there is support in this sense in prior work in order to expand its meaning. For instance, since interaction always involves some exchange of information, we can look at modality as the type of communication channel used to convey or acquire information. And this is a quote from a general perspective of modalities that can be found in the work of Nigay and Kutas. Also, since interaction always generates a form of experience, we can define modality as the way in which something happens or is experienced, which is a definition that comes from Baltrusitis and colleagues. These specific ways of looking at what modality is, such as information or modality as experience, are general enough to enable moving beyond the current vision or the current paradigm of human modalities supported by AI and enter the new vision that I'm proposing, where we use generative AI in order to create new modalities and support multimodal interaction that is distributed across humans and AI. Extending the semantic scope of modality across both humans and AI is thus a requirement in order to match advances in technology related to human augmentation and human computer integration with novel research in multimodal interaction. And this extension can lead to new forms of multimodal interactions and also advance multimodal user interface design. So to this end, I propose the perspective of AI as a modality uh, with a conceptual space that involves two dimensions. The first dimension regards the autonomy level of the AI embodiment. And in its simplest form, this includes the categories of full teleoperation, shared autonomy, and full autonomy. For instance, in full teleoperation, the human performs the interaction, and then you have the AI that provides support for the human modality, which is essentially the established paradigm that we've been discussing so far. Then, in the shared autonomy and also the full autonomy categories, we have this interesting opportunity where the human and the AI join modalities towards achieving multimodal interaction that is now being distributed across humans and AI. The second dimension of this conceptual space regards the spatial relationship that exists between the human and the AI embodiment. For instance, the AI can be embodied in a device that is remote in the environment, but it can also take the form of a device that is being worn on the user's body. When remote, this distribution of modalities takes place over a distance that separates the user and the AI embodiment. And this distance actually contours the two as distinct entities or distinct actors that put together modalities. In the on-body category, the distribution of modalities takes place at the scale of the human body, and therefore the user and the AI, they appear as two closely tied entities that are engaged in multimodal interaction. At this point, it is useful to discuss a few examples. The two figures that you see on this slide depict two use cases where the AI system supports interactions that are performed exclusively through human modalities. So this means that we are within this current AI as a tool paradigm. For example, remote teleoperation means designing systems that from the environment being external to the user, and by integrating some form of AI, they are able to sense users and react to users and overall assist users that are present within that environment. And common examples here include natural interaction with ambient devices, where you have specific input modalities that are used to implement remote control, such as proximity to specific devices or performing gesture commands in mid-air in order to turn on and off the lights in the room and so on. So these are the examples that are being shown in figure 1A on this slide. The role of the AI in this case is that of supporting technology for recognizing actions performed by users and providing a response that is suitable in the context. Then we have, in a similar manner, we also have on-body full operation, which means systems that are designed to be worn and that integrate a form of AI. And an example is, for instance, a smart wearable such as a smartwatch that dismisses a notification when the user looks at it, as it is illustrated in figure 1b on this slide. Now, we have the possibility to reconceptualize multimodal interaction by incorporating modalities that are delivered through AI embodiments. And this becomes relevant when AI systems expose semi-autonomous or fully autonomous behavior. And there are various combinations that are possible across the dimensions of this conceptual space, and they give rise to novel forms of multimodal interaction. For example, let's consider multimodal interaction in human augmentation through AI that is embodied within the environment. In this category, AI systems within the physical environment, they provide modalities that complement the user's own towards achieving a task through multimodal interaction that is now distributed across the user and the AI. So imagine a video projection of the user's silhouette that constitutes a new modality to reach within the physical environment beyond the physical limitations of one's body. In doing so, users are permitted to engage in new interactions that take place at a much larger distance than possible through existing innate human modalities. A fully autonomous AI embodiment would expose independent behavior from the user and therefore determine a totally different user experience in that environment. As an example, in my prior work, I've played with the concept of hybrid bodies, where a virtual arm is video projected onto a tabletop in a way that it is aligned with the user's physical body. And the virtual hand plays movements that are independent of those performed by the physical hand. And this results in bimanual interactions that require two actors, the user and the AI embodiment, which in this case is represented by the virtual hand. For example, the physical hand would hold a pen and the virtual hand a digital piece of paper. And this enables interactions that take place across the boundary of the physical and virtual worlds and across humans and AI embodiments. Now, let's consider multimodal interaction through AI embodiments that are close to the body and are represented by wearable devices. In this category, the AI system is integrated into a form factor that is in a close relationship to the user's body. And from that location, it provides the extra modality. For example, finger hints is a finger augmentation device that we designed for kinesthetic feedback. And it operates by placing the user's index finger into a state of hyperextension. And by doing so, finger hints trades off user agency for information delivery through the user's body. This process that is implemented by finger hints is actually a new form of multimodal interaction where the extra modality is delivered through AI embodiment. Okay, in this context, what are the next steps for AI as a modality? As we see technology advancing in human augmentation and human computer integration, there is a need for a roadmap to achieve the vision of AI as a modality. And I see several steps for making this vision a reality. First, understanding how multimodal interaction encompasses modalities that originate from both humans and AI embodiments is crucial. And this may require revisiting established models that we have today for multimodal interaction, such as case and care models, by integrating aspects that relate to AI, AI embodiment, autonomy, user agency, and so forth. Second, I believe that new conceptual frameworks are needed for multimodal interaction in human computer integration. And these include frameworks that capitalize on human abilities mediated by computer technology. Also, paradigms that incorporate multimodal interaction, which feature both natural and non natural input modalities. And I can refer you to our prior work on non natural interaction, which means interactions that are intentionally designed to evoke user experiences that are perceived as unusual, unfamiliar, and unconventional in contrast to natural interaction. Also, I think we need new philosophical and cultural frameworks to examine physical digital environments designed to amplify, to mediate, and to extend human sensory motor abilities and manage this shared intelligence between humans and AI. Third, there are new opportunities that arise in designing multimodal interaction across humans and AI embodiments in many application areas. And these also include understanding the novel user experiences of interactions that are multimodal across users and AI. All these directions, I think they promise an exciting journey for the scientific communities that will redefine the current understanding and scope of multimodal interaction towards our next generation of multimodal interactive experiences. And this concludes my talk today. Thank you very much for your attention, and I'm looking forward to having a discussion on this topic. Also, please check our other work in this area, such as non-natural interactions or interactions that take place at the boundaries of the physical and virtual worlds. You can find papers in these areas on my webpage or the webpage of the MintViz Research Laboratory. Thank you very much.